Hello DevOps friends, welcome to Full Stack Live. I'm Jochen, the Monospace Mentor, and this is my live stream, and I'm happy to have you here. Is it Tuesday already? Again. How does time even work? It's very strange. But here we are, another live coding stream, and let's see what we're going to get done today. I'm already excited to continue on the same project that we were working on last week. But first of all, hello everyone. Say hello in chat. How you doing? How has your week been so far? I hope you did have a great start. Today we're going to do some work on the simulation framework. Is that the right term? We'll see. On which I've been working last week, and that is going to become, hopefully, a great tool for me to visualize a network interactions for my courses and workshops. The thought behind it is, when we talk about systems interacting with each other, it's a good idea to visualize that, to see how a HTTP request goes from a browser to a web server, or what happens if we put a proxy server in between, or some kind of a load balancer. How does a microservice architecture look like when everything is interacting with everything else? And so I thought, how can I visualize that? Of course, you can animate something like this by hand, but that's a lot of work, and it's going to be very tedious, especially if you have to change things after the fact. So I thought, what if we can program that? Sounds like a programming project or a programming problem. And yes, so I had the idea to use the DragonRuby game toolkit to implement something like that. DragonRuby is a game toolkit using the Ruby programming language, which is my favorite language, and it allows you to animate stuff on screen. Of course, it's for games. So I thought, why not try and use this toolkit to not animate a game scenario, but a simulation. And last week I put in a few hours, and I already got quite far for a few hours, I guess. And today we're going to continue doing that. Hello, Moolol. How's it going? I hope your migraine has become a little bit better. Are you recovering? I'd upload your coffee, if I could. Yeah. What's the bigger headache? Having a migraine or having to do the taxes? My answer would be the latter. I think I'd rather have a migraine than have to do my taxes. But it's great for you to step by. Coffee got cold. How can that happen? Correlation or causation, yeah. The eternal question. What is the root cause? My coffee is almost empty already. I think I'll have to take a little break later to get a bottle of water. But yeah, I do enjoy the taste, and I hope it'll boost me a little bit. Other than that, I'm feeling quite all right at the moment. Everything is okay. Weather is terrible though. It's typical April weather. Rain and sun taking turns. So I haven't been outside yet, because just when I wanted to go outside, I turned my head, looked outside, and realized it was pouring. And so that plan had to be changed. So I guess I'll get outside after this stream. And that's my coffee gone. I'm drinking Japanese coffee at the moment. My regular subscription hasn't renewed yet. I guess we are going through those beans too quickly, and so I had to go to the supermarket and get some beans, and they had some Japanese roasts, and so I chose one of those. And it's pretty decent, I have to admit. It'll definitely bridge the gap until the next round of my bean subscription comes in. 7-day streak of going out for a walk every morning. Brilliant. I don't think I've ever managed to get 7 days in a row. Unfortunately, I pretty much fell off the wagon in terms of going outside in the morning. In part of the weather, but that's not the greatest excuse, I guess. So yeah, I definitely should push myself a little bit to go outside, if it's not just pouring and raining cats and dogs. But congratulations, that's a great achievement. Yeah, definitely, it's a great focus changer, or at least it's a little bit like meditation sessions as well, I guess, because if you don't blast a podcast in your ears, occupying your brain all the time, you'll see what surfaces, and you'll see which thoughts come naturally, and what is churning in your brain at the moment. And simply being aware of these things, to realize, yeah, those taxes, they keep nagging me, and I guess I should get this done, otherwise I'll never get it out of my head. Something like that. That just raises your own awareness of what's bothering you, and what is clamoring for your attention. And I think that's definitely helpful. I do enjoy that. Thankfully, I've become more open to have these thinking sessions, instead of, oh, that's great, I have another hour during which I can reduce my podcast queue. Oftentimes I start, sometimes it happens even that I start a podcast and then I walk a few steps, and then I realize, no, I'd rather hear myself thinking, and switch off the podcast and simply walk in silence and see what comes up. It is in part meditation. I mean, there are walk-in meditations actually, but you don't even have to formalize it that way. Just allowing your brain to surface stuff while you are outside. Motion also helps with brain activity, so that is definitely a great thing, and I'm really happy and a little bit jealous of you to get that whole week of taking walks in the morning. That means tomorrow morning is going to be reserved for a walk. All right, folks, so what else is there? Well, I'd like to announce a few events on the server room, my community of practice. The server room is a community of people who are interested in all kinds of dev/ops topics, software engineers, Linux system administrators, and so on. Alexis Surges, hello, welcome to the stack. And in the server room, we get together and not only exchange stuff, by posting on the forum, but also we're going to do quite a few things. And if you're interested in what these things are, you can simply go to my website, monospacementor.com. And on the news section, you'll find the events list. And here you can see up here is today's live coding stream. That's the live coding stream for Thursday. On Friday, I'm going to have my office hour here on Twitch. And here's where the server room as a community kicks in. While people are able to post questions during my office hour, most of these questions need to be pretty shallow, because if there are more complex questions, I would have to prepare or research something first before I can answer. And members of the server room have this opportunity because they can post their question to the forum in advance, give me a little bit of advance notice, and then I'll be able to also answer questions that go a little bit more deeply, that require a little bit of elaboration and research. So that's definitely one of the perks of being a member in the server room. Next week we'll only have the office hour on Friday, because I'll be off to Berlin to the DevOps days there. On Tuesday and Wednesday, there's going to be the DevOps days in Berlin, which I always enjoyed. Not only in Berlin, I've been to DevOps days London and in different countries as well. So I'm very much looking forward to that. Also, because I haven't been to too many conferences since COVID died down a bit. It did not die off, but it died down a little. So I'm looking forward to being in Berlin next week. But since I'm going to be there and I'll be traveling on Monday and Thursday, there won't be any live coding streams. The week after that, we'll have a live coding stream on Tuesday, and on Tuesday night, we're going to have our community hangout, which is another benefit of for members of the server room. It's simply a video call on which we have a casual conversation about everything and anything that comes to mind. It's always a great bunch of people who come together, and every time I'm amazed at the range of topics that we get into. I remember talking about Christian iconography in medieval times, and we'll of course also be talking about tech stuff like Kubernetes, our home lab setups, all kinds of stuff. So that's definitely also going to be an interesting thing. And later in May, we'll have the first deep dive session, where I'm going to showcase my Linux setup here, where we can actually go deep on how I set up my workstation, what decisions I made to set up my stuff, how I did, and get to talk about different alternatives and things like that. So that's going to be the upcoming events in the server room, and if you'd like to join us there, simply go to theserverroom.sh and you'll find all the perks and benefits and the different member tier levels that you can sign up for. Also in the news section on my website is the newsletter, News from the Server Room, where I publish my newsletter every week. You'll get a newsletter into your email inbox every week, every Monday morning, and it's free. And it's free of any fluff and marketing stuff. And so I hope to really provide something of value. And the feedback that I get from recipients, even fellow streamers, is positive. So I'm a happy camper. If you want to subscribe to my newsletter, simply go to monospacementor.com/newsletter. Okay, so that's that. Now, what are we going to do today? I'd like to keep working on my simulation framework. That's at least what I'm calling it for the time being. I'd like to be able to simulate network interaction between services, between clients and servers, between different server types. And I had the idea to use the DragonRuby toolkit for that. DragonRuby is a game toolkit, but I thought, hey, if we can animate stuff like bullets flying around, hitting a wall and exploding, why can't I also animate HTTP requests flying around, hitting a server and then getting dropped? So that's what I went and did. And this is how it's looking so far. I've built different namespaces. There's the DragonRuby namespace where I created classes that model the DragonRuby objects. For now, I have a sprite and a border object. We'll also have a solid object that can render, say, a solid rectangle, for example, while a border renders an empty rectangle. And then we have the simulation engine that basically manages a bunch of entities. Entities could be rectangles that represent services, and they can also be requests that go between these services. And each of these entities then gets to react to time ticking away. Every tick, which happens 60 times per second, all these entities get called to update their state, and that then creates the animation. And the animation that I've built so far is simply I've defined an endpoint as an abstract, which renders as a border at a specific position on the screen. An endpoint can be busy, which at the moment it stays for 10 ticks. And during that time, its border simply becomes red. That's the only thing that happens at the moment. And that busy state gets enabled when the endpoint gets hit by a request. And these requests are spawned by a sender, which is also an endpoint. At the moment, we have 2 requests per second. And so this sender endpoint spawns requests. And these requests then simply start wandering across the screen and going towards the receiver, which is also, as you can see, an endpoint. And here we have the request, which is apparently the most complex class at the moment, where we have a blue circle that gets rendered as a sprite. And in its tick method, we handle if the request has reached the receiver. And generally, we render the request, which means it just travels across the screen. And if we when we arrive, then there is about a 30% chance that the request gets dropped. Otherwise, the request gets accepted. And those 2 cases simply means how the final path that this request takes looks like. In the case that the request is accepted, it'll set its time to live to 10, which means it'll live for 10 more ticks, and it turns into a green circle. And if the request gets dropped, it turns into a red circle, and it changes its direction both in the X and Y direction, which means it'll bounce off, basically. And in that case, it'll live for 20 ticks, so just that we can see it bouncing off, otherwise it'll disappear too quickly. And that's that. All our simulation model has to do is to spawn a sender and the receiver, and that's it, because from there the sender will then send off its requests, and those requests will then handle their own life cycle. How does this look like? Let's take a look. We are in my game, so I need to go one level up here, called DragonRuby. And that's how it looks like. Here, down here we have the sender, which sends 2 requests per second. Each request has a random speed, and when they reach the receiver changes its state to busy for a short time, rendering it in red. I hope you can even see that. Some of these requests then bounce off because by random chance they get bounced, and they do bounce off in different directions because I've randomized that too. And that's it, but it's very promising, isn't it? That's definitely something that gets us in the right direction. And the next problem I'll have to solve is, at the moment, the request itself decides if it gets accepted or dropped, which is of course not what we want to model here. The request doesn't have a say in if it gets dropped or accepted. That's up to the receiver. And so the receiver needs to not only detect that it had been hit by a request, it also needs to then communicate its state or its decision to the request, so the request knows if it has been dropped or accepted. And this kind of interaction needs a little bit of work. To be honest, I haven't found the right approach for that yet. I have put a little bit of thought into it, but I haven't really found an obvious solution for that. So let's see if we can do that during this stream. It's Hap. Hello, welcome to the stack. Happy Tuesday. Now, let me think that through a little. Hope all is well says it's up. Yeah, it is. Thank you. And I hope you're having a great Tuesday yourself. So basically this part here needs to change. It's not a good idea that the request can decide by itself if it gets dropped or not. So we'll need to make a change there. It's Up says, I've been thinking about some theory stuff. What kind of theory stuff did you think about? So how does the request find out if it has arrived? It calls the intersect method with the name of another object, another entity. So this method checks if there is an actual intersection between those two objects on the screen. And it initializes in transit to true when it starts. So usually it's in transit from the start, but once we've hit the receiver object or entity, in transit becomes false. And in that case, there's also no event handling here or collision handling anymore. Yeah, that doesn't have to be, because we immediately make that decision if the request gets dropped or accepted. So this needs to be replaced. Itap was thinking about how many WordPress sites can be run on 2 GB of VRAM if they have basically 0 users. That's a tricky question, actually, because WordPress, I think, tends to use up a lot of RAM anyway, regardless of how many requests it needs to handle. I mean, it'll only go up from with the number of requests, but I'm afraid. I mean, I don't have any current numbers at this time, but I'm afraid that the baseline RAM usage of WordPress is already not too great. Looked at some Docker estimates that WordPress is about 60 megabytes. So that would be 30 WordPress instances. I guess you'll have to make that an empirical experiment where you actually spin up WordPress and see how much RAM it uses, because of course there's also a difference between a vanilla WordPress and WordPress with additional plugins installed. So that's definitely something that you want to test. Okay. I'm not too happy with objects having to call intersect themselves to even trigger events, but it's a way to do things, and we might find something different later. I think what I'm more interested in at the moment is how this intersecting, this collision check then triggers results or consequences. One way to do things here is we could check the intersection, and then, since we are already we've already identified whom we want to hit, and at the moment that's actually hardwired, because sender and receiver are on the same vertical axis, and the vertical velocity of these objects is always upwards, so they are bound to hit the receiver. This will change when we have multiple receivers, and then we need to actually aim at our receivers. But that doesn't change the fact that a request needs to know its receiver in advance, not only because it'll have to plot a course towards that receiver, but also to check if it intersects. And then we could actually try and get the receiver entity itself and ask it if the request gets accepted or not. I think that's an interesting first way to go. So I guess what we could do is do something like, even when we initialize, we say destination. Let's give a request a destination attribute, and we call that, we'll use the name of the object for the time being. And so we can actually add that here. That shouldn't change the behavior in anything, in any way, but it does. Interesting. How is that possible? Bounding box method missing on a nil class. It calls... I think I know what's happening. The game doesn't get fully reset when I write a change to the code, and now there were objects around that didn't have this destination attribute yet, and still we tried to call intersect on that field. That is of course nil, and intersection with nil of course doesn't work. So all we have to do is actually restart the game from scratch, and yeah, it still works. Now, I can't do much with this string alone. I'd rather need to have an object. And the question is, how do we tell the request to aim at our receiver object? Itsap says, also wanted to learn about Terraform and Ansible to automate user setup. That's a great idea. Since the situation around Terraform is pretty dicey at the moment, I'd recommend using OpenTofu, but yeah, but technically it's pretty much the same. And then use Ansible to set things up. Yeah, I think that's a good idea. Definitely worth exploring. I'll also explore this further with my course student setup, where I also want to use Ansible extensively to automate the provisioning of student resources, which is going to come in handy when we do the community workshop that I've planned. I'm working on a community workshop for setting up a simple statically generated website on a small VPS using Jekyll, Apache web server, and Searchbot to get SSL requests. And yeah, we'll need something like Ansible for that. Not during the workshop, but for me to prepare the workshop. Okay, so I'll take a short break while the ad is still running. Yeah, I think I'll grab a bottle of water quickly. I'll be right back. Alright, I'm back. And I think I have a good idea how to fix these things. What we need is we need to tell the sender where it's supposed to send stuff to. And then the sender can tell its requests the same. So what we need to do when we set up our simulation is create the receiver first, So let's grab the receiver, put this here. And then we'll create the sender. And I'm not even sure if we need that name anymore. It might become obsolete soon. But for the time being, we'll keep it. And we'll add... for the time being, I'll simply call it receiver. And we'll pass it the receiver object that we just created. And why is that not... Okay, align the keys of a hash literal if they span more than one line. And avoid comma, okay. How's that not aligned? Am I supposed to align them all? Actually, not sure. We cannot just do it this way. Oh, it's because, yeah, the hash. Yeah, so this is how it's supposed to be. Self is a scalar value, and only after that we have the hash with the key value pairs. So this is supposed to be indented like that. Okay, nice. So yeah, we have the receiver now passed into the sender. The only thing is that we also need to initialize the sender with that information. So we need a initialize method with the engine and the attributes. Then we'll have to call super for the superclass to take care of everything, but the superclass doesn't know about the receiver attribute, and so we need to handle that ourselves. Attributes receiver. Is that correct? We have an endpoint. How is the endpoint initialized? Yeah, engine attributes, and then we'll simply have that handled by our superclasses. Okay. And we can again make attributes an empty hash by default. So now we have a receiver, and we'll have to pass that into our request as well. That is going to be at receiver. So that's that. Receiver then in turn gets that as well. No, it's a symbol. And finally we have an object that we can use for intersect, and I think I like that much more than passing a string that then gets looked up as yeah, gets like looked up in the hash and only then returns an object. I mean, for the time being, for the game to still work, we can pass in the receiver.name, which should still work. Yep. Okay, and that means now we need to change the logic a little bit, breaking the game in the process for a short time. So instead of a name that then gets looked up and which returns an object, we'll pass in the object directly. And intersect is a method in one of these superclasses. And I'm pretty sure it's in the entity. Wait, where's the entity? It's up there. Here we have the entity. And intersect gets an object or an entity. So we need to pass that to the engine, which now also needs to accept two entities. That's entity 1. Entity 2. I mean, it's true. If entity 1 bounding box intersect rectangle, entity 2 bounding box, then I guess we'll call target hit. No, we'll call nothing for the time being. Oh wow, and look, it works again. Interesting. I'm actually surprised that it did recover, but there is one difference. I'm not sure if you can actually see it. The bounding box does, or the box of the receiver square doesn't change color anymore because I've removed the hit method. Frame rate warning, but that's only because the window doesn't get enough resources while it's not focused. That shouldn't be a problem. Okay, so my thought was either we call hit for both entities, or we call hit for neither. So if we call it just for entity 2, then our box changes color again. And I guess it's only fair to also call hit for entity 1. Which means we don't actually have to handle the collision directly anymore. We can change that, which I find much more compartmentalized if we can actually simply call intersect here. And we could simply call intersect in tick, actually, where we render and then check for a collision. And if that happens, then we'll have another method prepared, which still needs to be written, which is the hit method. And that then takes care of the event, which leads the way to a more event-driven architecture. So I think that's a good idea. By the way, if you don't think it's a good idea, or if you have any suggestions or questions, post them in chat. Let's make this show interactive. Good old dihydrogen oxide. Yeah, why not, actually? So, what happens if we call intersect at receiver for every tick if we are in transit? If not, we are in the end game and need to see what happens. And we don't have to do handle arrival anymore. And we could actually move intersect up here. But since we don't call handle arrival anymore, we'll have to define the hit method. And we'll have to pass in which entity we actually did hit. At least we'll have to do that in a more general use case. In this case, it's pretty clear what we hit, but so that's that. And when we hit something which can only be the receiver in this scenario, we'll set in transit false, and we'll still, for the time being, decide if we get dropped or accepted. That means this should work too. Wrong number of arguments. Oh yes, are we already passing in? Oh yeah, I did make a mistake here. Of course, we call... Ah, look at that. I didn't read it correctly. I already made it this way that we can say, call entity 1 and you hit entity 2, and we tell entity 2 that it hit entity 1. So we are already passing in the object that was involved in the collision. And those are actual game entities or simulation entities, which is brilliant. We just need to define hit as a method that accepts an argument. And now we can change this condition. We can actually ask the other object that we hit, which is the receiver object, we can ask the receiver object if we are accepted or dropped. So what we can do is build a condition here if entity name equals at receiver, which is the if entity equals receiver, if those are the same objects, only then we do this. That should be true all the time, because entity will always be the receiver. What else could we hit on this screen? But it might be different in the future. And then we can call receiver connection. Or what's a good name for this? We call it connect. We try to connect to the receiver. Basically, our electrons have traveled through all the cables and have reached the receiver machine, and now it's knocking on the door and says, "Can we connect, please? I came all this way." And if that's true, then of course we'll do request accepted, otherwise we'll do request dropped. Now that I've saved this, of course the game stops because receiver doesn't have a connect method yet. The receiver doesn't even have a special method at all, but that's not a problem. Actually, we can make this a behavior of the endpoint class, which is a superclass to receiver and sender. It's just not relevant for sender. When a request hits the endpoint object, it, as I explained, it switches to busy state for 10 ticks. And how about we define connect as not busy. So if the endpoint has just been hit by a request, that request will get a connect true, but for the next 10 ticks, the endpoint will be busy, and requests that arrive during that time will be dropped. So this should look a little bit more realistic now. It's a little bit hard to see, but yes, as long as the requests come in with a little bit of delay or with a little bit of an interval between each other, it works. But as soon as they arrive in groups, yeah, the slower ones get rejected. That is amazing. Cool. Yeah, let's give this window a little bit more frame rate. Awesome. If there's a group of 3, 2 get bounced, 1 gets accepted. Oh, how did they get accepted? I think there is a little bit of a race condition there. And how do we still get frame rate warning? Are we doing a little bit too much here? Can't be that problematic. Did we somehow build recursion into here? No, I don't think so. Let's see. If I increase the busy timer to 20 ticks. Yeah, now it's a little bit more obvious when they arrive a short distance from each other. And there's always only one that gets accepted, right? Let's let the ones that get accepted travel and live a little bit longer so we can actually see if there is any problem. But as far as I can see, only one gets accepted at a time. And we could increase the busy time a little bit more, actually. Is that hardwired at the moment? Yes. Busy is in the endpoint up here. Yeah. Busy timer is 20. Let's make it 30. Half a second of busy time. There are still some that get through, interestingly enough. Even though I don't think they're 30 ticks apart. Let's make it 60 ticks, 1 second. There's always one. Yeah, now it's visible. Oh, now they all get rejected. How didn't we get out of busy state? Ah, yeah, that's because busy state gets triggered every time the receiver gets hit. If it can't reset, then it stays busy, which is of course not the case. Connect needs to create the... Wait, connect? Only a connection should trigger the busy timer. When do we... Yeah, I think we'd say return false if busy. But if we're not busy, then we'll enter busy state. Enter busy state. We still handle the busy state. Yeah, okay. And hit doesn't enter busy state anymore. Which is actually a good idea. That's not what happens though. We should accept one and then only stay busy for 60 seconds, or 60 ticks, which is 1 second, and then we should be able to receive again. And I don't think that's true. It's not like what it looks like over there. Let's restart the game. Yeah, that looks more like it. After a second, we are ready to receive again, and in the meantime, everything gets dropped. It would be nice to have an animation that shows the busy state. That's definitely something the endpoint should have. And we could do that, actually. By simply using another circle. The nice thing is the default circle sprites that come with DragonRuby have this notch. And by rotating them, we could actually have a little bit of a clock effect there. So let's try and do that. In render, we'll call render busy. And render busy will create a new sprite. Where's my request? We can steal that sprite from here. And we'll say we create a sprite. At our position as a 40 by 40 green circle, and add that to the sprite's output. Boom. Args method missing on receiver. Yes, of course, yeah, render busy, we need to pass in args as well. And of course that only happens if we are actually busy. Okay, that works. It appears as long as the border is red. We can make it a little bit bigger. As big as the receiver itself. Actually, we could use our own width, to be honest. We initialize ourselves. Okay, that's hardwired too. So yeah, if we hardwire that, why not make it a constant then? We'll call it size. Why not? And we'll use that here, and here, and here, and here. So it's always going to be the correct size, and then we'll have to pass in a little bit more. And I'm not sure what the attribute name is. Let me see the... I can't actually see that in the code here. Because we're using attr sprite, which is predefined by DragonRuby, and I don't see... Well, we can actually... sorry. We can actually go into the samples. No, it's not samples, it's docs, OSS, Dragon, attribute sprite. And there is some kind of an angle. Wait, how is there an angle X and Y? Ah, there's an angle attribute as well. Okay, let's use that. So here we'll use angle, and in that case we can use busy time. Times 10, something like that. That didn't work. Method missing. Timer. It's busy timer. Yeah, but there is no angle. Okay, let's look this up. docs.dragonruby.org. And outputs. Sprites. Anchors and rotations. Angle, rotation of the sprite in degrees. Rotation occurs around the center of the sprite. Point of rotation. Oh, okay, the anchor point for the rotation can be changed, okay. But for the time being, I think angle should do the trick. Why doesn't it? Because... no, I don't know. It should rotate backwards because busy timer starts at 10. No, it even starts at 60 at the moment, right? Yeah, we enter busy state with 60. So it starts basically with an angle of 600. And then it should count down. So it should actually turn counterclockwise if I get it right. But that's not the case. Let me see. We could also try and simulate something about the size. If we use the busy timer as our size, it would start big and then shrink down, which is also an interesting effect. Maybe I'm not going to keep it that way, but since width and height seem to be working fine. Yeah. So that actually works, and until the timer has expired, everything gets dropped. Yep, I like that. But of course we'd have to change the anchor. Maybe we have to change that anyway. Let me see. It's angle anchor X and angle anchor Y. So angle anchor X. Is that just size divided by 2? And angle anchor Y. Also, is that relative or is that a screen coordinate? We'll see. That's not even a difference. Yes, of course, because we're still not turning at all. So the angle anchor, of course, doesn't do anything as well. So our sprite would have to change its position as well. Because at the moment the position is the lower left corner. But I think I'm wasting my time in animating the size of that thing instead of it having it turn. So what's the problem here? Somehow angle doesn't get passed through. Ah, yes, of course. Because it doesn't get passed through. While I'm defining attr sprite, we don't initialize it. Do I have to initialize all of those by hand? Ugh. I think we need some... what's it called? Self-modification here. For the time being, let's pass in angle. And that also needs to be serialized. I do not like that. In the end, we'll have everything in here. But yeah, now it does. Okay. We have at the moment a busy time of 60. So at least I don't need the anchors at the moment. So I can simplify things a little bit here. Our busy timer is counting from 60, so we can actually say take it times 6 and it'll make a full rotation. No, that's not a full rotation. That's not a full rotation, is it? Let me see. Let's spawn less requests. Yeah. Okay, it just starts at the 3 o'clock setting. Okay, so we could add 270. I think it'll probably do this modulo, right? So let's see, where's my endpoint definition? If we are busy, we'll say make it 270 plus the busy time times 6. No. Now it starts at the bottom, doesn't it? Is it just 90? Yep. Okay. Okay, a lot of stuff still is hardwired in here. We should probably define a few more constants. For example, the busy duration. Make that 60 for the time being. So we'll use that constant here. Busy duration. That allows us to also say busy timer times 360 divided by busy duration. And that way we can actually change busy duration and it'll still make a full rotation. So if we now reduce busy duration, or maybe even increase it, let's make it 120, 2 seconds. One, two, one, two, one, two, one. Yep, that works nicely. And let's not have my requests travel for that long anymore. That was just a temporary thing. TTL should be pretty short. Let's make it 5 ticks so it does disappear quite quickly. Yeah, just looks like it gets swallowed by the endpoint if it doesn't get rejected. That is awesome. So we don't have to render the border in red anymore for the time being. I think the visualization with the clock is already quite nice. Where does the endpoint get rendered? Somewhere here. in handle busy state, we set the border color to red or 0. Show busy state. Oh, okay. Actually, render busy should be called by handle busy state. Or rather, wait. We have handle busy state and render. Render is the endpoint itself, and handle busy state is something separate. Fair enough. Then we can actually take this out of here, because it already gets handled by handle busy state, where we say show busy state, and we'll change that to render busy state. And let's move connect up here, enter busy state, handle busy state, render busy state. That is easy to read, should still work, hopefully. Oh no, it doesn't! Because we don't pass in render busy state, we pass in args to render busy state, which we then also have to pass into handle busy state. Okay, down the full chain of calls here. Now everything works again. And yeah, I really like how while the clock is turning, requests get dropped. Some arrive just in time to get accepted and keep the clock turning, but yeah, this works nicely. I really love how this works. Now, if we change our busy duration from 120 to 30 ticks, that means more requests will get accepted. Yeah, that one was too fast. Huh, I'm really happy with this result. What do you think? Is there a way to zoom in to the game? No, that wouldn't be. Unfortunately, I can't change the resolution of that. It's always 1280 by 720. Okay. Now, let's have our request plot its own course. Maybe we'll go and commit this. I think that's a good idea. I need to change things a little bit. I'd like my shell number 2 to be my working shell, and in shell number 3 we'll do the... oh no, that's an example. We could as well split this. And here we'll go and call DragonRuby, and up here we'll do, oops. Oh, what's happened here? Receiver, inspect, receiver. For render busy, method missing on receiver. Huh? Render busy. Let's take a look. It's render busy state. Where does render busy come in? We have render busy state. Render busy? Oh, in render. Yeah, let's remove that. So that's basically render yourself. And the other stuff is what's happening in internally. Okay. Fine. And now, yeah. As you can see, our request gets initialized with a vertical speed that is 1 plus a random number. So once it starts, once it gets rendered, it will automatically travel with a Vx of 0 and a Vy of this value. And now we'll have to change that. We'll basically calculate that depending on where the receiver is, because now we know the receiver. So actually we could go ahead and say, okay, our Y speed is the receiver's position minus our own position divided by 60 would mean we always arrive within 1 second. Let's make it so they will all have the same speed, and basically that's of course our x velocity, and we'll do the same, which should always be 0 divided by 60, and the y position is that, and that means we can delete this, and we'll move this down here. Now it does work. You can see it aims at the lower left corner of the receiver now, which is funny. It does work. The formula does work, but we need to jiggle the coordinates a little bit. Balthazar, how are you doing? Welcome. So yeah, it's plotting its own course, but now we are spawning requests on a steady rate, and so there won't be any rejected requests. Welcome to Tuesday, Balthazar. It is going well. I'm having a lot of fun, and things are going according to plan. As you can see, I've added a little bit of an animation that visualizes the endpoint being busy. Every time a request appears or connects, every time a request arrives, it asks to connect, and if we are not busy, we get busy, process the request, and that gets this clock turning. And since we are sending requests on a steady rate, which is, I think, just our busy time, we don't get any rejects. But if I increase my spawn speed from 1 to 2, from 1 second to 2 per second, where are our RPS? Here's RPS. So let's make 2 requests per second, and I think we have a half-second busy time. Does that now create? No, that just keeps the clock turning continuously. So we need to increase that to 3, which means every 3rd request will now be rejected, right? Let's see if that's the case. Yeah. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yeah. But it's a little bit hard to see. So what we could do is send 2 requests per second and make our busy time a little bit higher. Busy duration is 30 at the moment. Let's make it 40, something odd. Yeah, that means every now and then we'll get a drop. I love it. It's a simulation and an animation. I'm getting both. We might see a load balancer in a few minutes. Okay, this is going great. I would like the speed of no, let's vary the spawn rate. At the moment we have a static spawn rate of 2 requests per second, and I think it's more interesting if we vary that. So how about we make this random and say, okay, instead of working with RPS, we'll say something like spawn window (60) at least every second. This is always going to be in ticks, so we always have 60 ticks per second because the game runs at a steady 60 FPS if you don't botch it up. And we'll modulo by rand spawn window. So our modulo will vary. Oh, that broke it. Divided by 0. Oh, can spawn window be yeah, the rand. Yeah, okay. Rand can probably be 0.2. Uh-huh. Okay. Of course, that's a little bit too fast. We've built quite the cannon there. So I guess we'll do something like spawn min, which at the moment is 1. but we'll change that. Here. That's going to be spawn min. And then we'll say spawn max. We'll make that 60. So at least every second, and we'll simply say rand spawn max minus spawn min. Same behavior still, but we can now increase spawn min and say, okay, let's do at least 30. Let's give them a little bit of yeah. I love it. I love it. I'm a game dev now. Look at it. Beautiful. It's so much fun seeing stuff that you're coding visualized like this. Okay, let's take a break during the ad break. This is so cool. I think next we'll work with 2 receivers and do a round-robin algorithm. And then I'll have to think how I'm going to actually do this in terms of different scenarios. Look at them. If it fires a series, they bounce off. If they come one by one, there's a bigger chance for them to get accepted. Love it. Yep, works as intended. Okay, so let's go down to our simulation. Here's the model of the simulation, and here we create 1 receiver. How about we create a second one? We'll position it at the same y coordinates, but a little bit left of the original. So that's going to be receiver 2. And of course we'll have to rename that to receiver 1. And then of course we need to find proper data structures to handle those, because I don't want to hard code 10 receivers, but baby steps. So this should still work as intended with a board second receiver. Let's see if this works. It doesn't get initialized anymore. Okay. Yeah, something like a receiver factory, exactly. And of course we'll have to pass in all these receivers to our sender. If we regard our sender as a load balancer, then of course it needs to be informed of all the receivers that are available. But as I said, baby steps. Let's restart our simulation first. Completely. Why no second receiver? That is strange. What did I do wrong? Receiver 1? Receiver 2? Oh, they have the same name. Yeah, I think we need to rethink the naming schema here. Interestingly, the receiver 2 didn't get added because the name was already taken. Maybe we should fail the whole program if a name is already taken, because I didn't notice and it got dropped silently. So let's restart that again. 2 receivers. Nice. Two receivers is going to be the name of my next 80s revival song. Okay, that's nice. I guess a sender should now get a list of receivers. And that sender will now get new behavior, because now we need to add a load balancing algorithm, something like round robin. And that gets us to the top level structure of our whole simulation code. How do we properly model all these different scenarios? And why don't we have a namespace here? Okay. We don't, because, yeah, that's basically the top level. Okay, fair enough. Can live with that. What's that? Use a guard clause. Okay. Not sure if I want to have a guard clause there, but that style is something that I'll deal with at a later stage. So, I guess we'll have to start separating stuff out into different files. This was nice as long as it lasted, but we definitely need to get more structured. You know what? I need a bathroom break anyway, and I'll use that to think things through a little bit more. I'll be back in a few secs. And we're back. Our request cannon is still shooting. And that works nicely. And I did actually think of something. Because, yeah, this sender is basically just a very special kind of endpoint. It's not as general as I regarded it to be, simply for the fact because it's the only one I got. It's basically a random request sender or a random request cannon, whatever. And it has these two parameters where it'll spawn at least every 30 ticks and at most every 60 ticks. And so we could call this class like random sender or something like that, and actually initialize it with our two values here. And that way, oh, thanks, Balthazar. Yeah, I need a thesaurus. Emitter. It's a request emitter. A random request emitter. That's definitely it. So what I'd like to do is basically split stuff up, extracting things into different files now. Not sure about different directories. I guess we'll take it step by step. So let's actually move stuff out. I'll definitely be able to extract the DragonRuby abstractions for sprites and borders, because we haven't touched them in quite a while, except to add the angle attribute there for our clock to be able to turn. But other than that, we didn't touch that much. So I'll create a new DragonRuby.rb, and here we'll extract this whole part here. Attribute border, I didn't take attribute border into the DragonRuby module because attribute sprite isn't either. Attribute sprite gets provided by DragonRuby, strangely enough, but there is no attribute border. It's not predefined, so I had to do that myself. So let's take all that, extract it to here. We'll also need to add the frozen string literal comment here. And in main, we'll simply do an no, it's a require relative. DragonRuby. Saving that. Should still work. Yep, does. And then we'll also extract the simulation engine. And these simulation classes like entity. Yeah, that's it. And we'll also take this opportunity to rename engine into model, because that's the proper term in simulations. It's a model. Copper Beardy! Long time no see! How's it going? Greetings! Happy to see you again. Hello? Oh man, good old times. Love it. Yeah, so we'll extract that too. So we'll need a simulation.rb, simulation.rb. We'll start by extracting all that stuff down to here. Also, we'll need the frozen literal. Let's keep it this way. Okay, let's save that. And in main, we'll simply require simulation. Okay, that makes navigating my code much easier, because now this is of course a simulation. And you know what? Endpoint and that stuff is just another layer of abstraction where we're talking about network or services, something like that. Copper Beauty says, doing okay, hope things are well for you. Yes, they are. I am doing great in general, and today on this stream as well, because building my simulation here using DragonRuby, a game development framework, is just so much fun. Seeing stuff bounce around the screen. The thing that I want to simulate here, and yeah, that's probably not apparent, is network services that talk to each other. So down there you can see the request emitter. It's basically a client sending requests to a server, and that server then takes a little bit of time to process a request, and requests that arrive during that processing time get rejected, and you can see them bounce off in a red color. And now I have to refactor my code a little bit, because we are at a point where everything needs a little bit more structure. And yeah, I think there is going to be one more file where we actually define these generic network simulation objects. They are all based on the generic simulation object, simulation entity. So yeah, let's extract those too. So how am I going to call this? Network? Network might be a little bit too generic. But it's, I guess, it still applies. Yeah, I think network does it quite well. If we allow network to be any level of the ISO OSI model, then those can be network packets, they can be IP packages, or they can be HTTP requests. So yeah, let's call that network. And that means we can actually extract endpoint and sender and receiver and request. Let's extract that into network. And in main, we'll just require it. And that just leaves our model here. That code is definitely easy to navigate. It's just one page. And that now allows us to identify the entities a little bit better. Because this sender is not just a sender. That it's not as generic as that. The sender. Do I even separate that into separate files? We usually do one class per file, don't we? I think, yeah, this is a good opportunity to do so. We'll just have to rename that sender. It's actually a random request emitter, which is still going to be an endpoint. And we'll probably then have to split this up even more. So let's call this random request emitter. And it'll probably then get two more attributes, namely the spawn min and the spawn max, which makes those constants obsolete. And we can work with spawn min, basically at spawn max minus spawn min. Let's separate that super call as well. And which means in our model, I can actually say, okay, let's create a random request emitter with receiver 1 and our spawn rates. Now I can control the spawn rate right from the simulation model, which I think it makes much more sense. So we'll say spawn min 30 and spawn max 60. That is that. And when we restart our simulation, things hopefully still work. Yep. But things are a little bit cleaner. Love it. So now we can control the spawn rate right from our central simulation model. And yes, this is a simulation model, not a simulation engine. So I guess it's also a good time to rename that. Okay. What I'm going to do now, yeah, I think we should split stuff up into files because that makes it easier for me to navigate as well. I don't have to scroll that much. So let's start by extracting the random request emitter into its own file. Random request emitter.rb. And in here, we'll simply say require relative random request emitter. So we can actually remove this, add it here, save it, and do it like this. And yes, I can see a directory structure emerging here as well, because yeah, we're going to create a lot of simulation classes or network classes even. And so yeah, I think we'll have a network.rb and a subdirectory network where we actually move stuff like the random request emitter. So let's make that a file in network. And so the this works like this. Okay. And why not do the same with the endpoint, because that's quite the big class here. So let's cut that and add that here, endpoint.rb. Put this here. And then we'll include the endpoint. Request deserves its own file, definitely. So let's create a request.rb. Nice. Stuff getting cleaned up. Let's also require the request. Nice. Okay, our receiver. Doesn't have any custom code because the endpoint takes care of everything that is related to receiving. Which might not be correct, actually, from a modeling perspective. An endpoint could be a sender or a receiver, so I don't think a sender should even have a connect method. Or this busy state. That should be part of the receiver, actually. So yeah, let's create our receiver here. And then here we have the random request emitter. We will definitely also change that. Maybe we should also have a more generic sender class, but that hasn't emerged yet, I guess. So, wait, I wanted to extract this functionality here into a receiver. And for that, we need to extract the receiver. Where is it? We are in endpoint, so I guess that's still left in network, right? Yeah. Yeah, let's take this, put it here, And in endpoint, we'll extract this functionality. That's not part of a generic endpoint. We put that into receiver. And that means when I save this, things should still work. But I'll have to actually reset the whole application to see if everything still works. No, it doesn't. What did go wrong now? Receiver for handle busy state, method missing on receiver. Handle busy state. That's... Oh, I see. Yeah, the tick method of an endpoint should simply consist of rendering itself, but not handle the busy state. So we'll need a tick method in... Yep, we need a tick method in receiver. And yeah, pretty much at the top here, I'd say. And that tick method is supposed to call super. Okay, add break. I'll take things slowly. Let's grab some water. This is definitely different from my usual fare of content. No infrastructure stuff, at least not actual infrastructure stuff, but we are visualizing infrastructure stuff. There is, of course, a connection to what I'm doing usually. That should be almost through now. And we're back. Bethesda says, it's honestly quite neat, and at the end of this you'll hopefully have a really cool framework that you and maybe other folks can use to build animated systems diagrams. Yep, that's the goal, and I'm definitely going to open source my code. I can't, of course, open source the DragonRuby framework itself, but DragonRuby is actually quite affordable. Very affordable, to be honest. So people who want to use this will be able to. And yes, I really am looking forward to getting this full framework where I can say, okay, let's get a load balancer here and a caching proxy there, and they behave differently and visualize their stuff differently. And let's connect everything together and aim a request cannon at everything and then see how things work. And maybe even make things interactive. I mean, DragonRuby does have, of course, interactive elements where in a game you need to be able to click a lever or something like that, or to push a lever with a specific keyboard shortcut or something. And so we could make the simulations interactive where you can, with your keyboard, raise or lower the request rate. You can raise or lower the processing time for requests, so the busy time of our receiver and things like that. So yeah, that's what I'm envisioning here, and I can see it coming together, to be honest. So now my tick method needs to get the handle busy state call from our generic endpoint, which will not have it anymore. Interesting. Now it's missing The connect method is also missing from receiver. That shouldn't be the case, but maybe something else is still awry here. So the receiver has now the receiver specific stuff. It has a tick method that calls super, which gets our endpoint rendered, which is just the square. And itself, it handles the busy state, which then draws the clock, if it's busy, where we can enter the busy state, and maybe we should also have an exit busy state method just to be symmetrical here. Exit busy state, and that's just this here. It's almost trivial, but I still like the symmetry. And it's easier to pinpoint where stuff happens. So the handle busy state is basically just handling the timer. Okay. And connect is where we enter the busy state. Okay. And actually we need to explicitly return true, which might not be the case. Might not have been the case. It did work by coincidence, but we either return false if we're busy, or we enter the busy state, but still return true to the request that wanted to connect. So that's that. And not sure why things are still failing. It probably require a restart. Oh. As soon as we try to connect, that method is missing on receiver. Well, it's not, is it? Wait. The method named connect doesn't exist on receiver, which is a class of receiver. We have the position 500, X position 600, so that's the right, yeah, that's the right receiver. They don't have any velocities, receivers don't move. And it's, it has a border, yeah, that's correct. And it has the name receiver, which it shouldn't have. Why does it have the name receiver if you have two receivers? In our main.rb, oh yeah, it doesn't, I didn't add the one here. Boom, still explodes. We are passing in receiver 1 to our sender. But receiver doesn't offer a connect method. That's strange. Actually, everything down here should be private. Oh, wait. Wait. Do we? Yeah, we don't include receiver. Here we go. There were a few requests flying off that didn't get handled, and I guess they're still flying. They just left the screen. But yeah, now everything works nicely again. Okay. So, I mean, in a real setup, we'd have the sender And that sends a request to a load balancer, and then that then acts as a proxy and passes stuff on. I'll keep things simpler and build myself a sender that is able to deal with multiple targets, multiple receivers. Does that make sense? Is it worth investing time into something contrived like that? Where would we build this? So we have to basically build another random request emitter. It's basically going to be a multi-point request emitter. And the only difference is it accepts a list of receivers. Well, we can extend our random request emitter to basically just allow a list of receivers, right? So we'll change that to receivers, which is going to be an array of receivers. And we could simply build a random request emitter by saying receivers sample. That's going to break because we haven't passed in any receivers, but that's up to our model to do so. So we'll simply make this an array. And sample doesn't exist. Okay, why is that nil? Probably because we need to restart completely. Look at that! Isn't it amazing? This is so much fun. I just added another receiver to the list. Ooh, there's a huge pause in between. And requests, if they are too numerous, they get dropped. Ah, you can't imagine how happy I am. This was what I dreamt of. Ah, I just relish in the feeling. Look at it. Shall we create a few more receivers? Of course we shall. We'll have to basically create this as a loop, I guess. So let's do something like 4 times do. We'll say receivers equals empty array. 4 times do receiver is we'll add that entity to the model, and we'll also add it to our receivers list. And then we'll just pass in our receivers. We'll have to restart our model. Of course, they are now all at the same position. We do have 4 receivers, I would assume, but you can't see them. Because we need to stagger the X position, I guess. Wait, that's going to be We need a counter. 4 times was so elegant, and I actually don't know how to get a... what's the best idiom for a counter loop? It's 4 times to count. Yeah, we just get the count. I expected that, but I didn't want to use it without verification, so I don't look stupid. We'll call it index, because that's what it is. And the X position is, we'll start... we'll have to start at the left, so everything will be a little bit skewed to the left, but we'll see. 100 plus index times 80? Something like that. And Robocop wants us to make this more explicit, so let's see. Let's split this up. We do position X and position Y like this. And restart the model. Oh, only one? How is there only one? Oh, naming. I still have that naming thing. I think we'll simply get rid of that name. There is no real use in... Oh, interesting. Where are they? They are phantom bouncing. Oh, yes, they are. Interesting. I mean, I could, of course, always do something like this. But this name doesn't serve any purpose anymore, because we are working with real object instances everywhere. So I guess we could simply drop that. No. Ah, yes, here we go. I guess we could simply move our sender. But look at it, isn't it beautiful? We need to up our rate, otherwise we won't see any drops, not many at least. But this is amazing. We need to stagger them a little bit more, I guess, and move our sender to the left. So if we start at 100, let's put our sender at say 250, something like that. Oops. And we'll stagger them by 100. Yeah, that looks much better. Contenance. I'm having so much fun right now. Oh, it's so good to see that when I thought maybe we can do it this way, maybe we can simply try and build a simulation engine. And look what I got done in just a few hours of work. Maybe I shouldn't be as pleased as I am, but I guess it's that I love it when a plan comes together moment. Because, yeah, I did not find myself in any dead end or something like that. It was just about getting the right approach. And yeah. Now let's start modeling, shall we? You are of course right, Balthazar. This is definitely cool as shit. I love it. Oh man, maybe we should commit something, huh? Let's do this. Let's call it cleanup. I mean, cleanup doesn't do it justice. Cleanup does not only include the splitting up in different files, it also has the 4 receivers and a random request canon here. But whatever. Now. Cool thing is I can just increase the number of receivers at will. And the model will simply adjust. Now our request rate is definitely too low. But there are still drops, thanks to randomness. If it sent its requests in a round-robin fashion, I don't think we'd see any drops at all. And I guess that's going to be our next step, actually. So we did build this random request emitter. And I'd say, let me take a look here. This part here is actually the heart of everything, and that needs to be extracted, actually. That shouldn't live in tick, and those underlines is Ruby telling me this needs to be extracted. Actually, tick is probably too... Yeah, it's too complex. Okay, and what's that? Use a guard clause. Okay. So, we might be doing that. We might do that. So, I guess we'll simply call this method spawn request. And we'll have to pass in the arguments. So we'll call this spawn requests, pass in the arguments. Oh no, it's just a single request, if at all. And we can even extract that to... Yeah, we'll make these private messages, messages or methods. It's basically the same in object-oriented design. We'll call this the spawn condition, which it is. And we'll have to pass in args again. And we'll move that here and simply say this. And say spawn condition. That's that. And yeah, now we can actually use the guard clause in a more maintainable or readable way. We can actually say return unless spawn condition, and then we don't have the conditional here. Unless and now the actual what I just noticed here is that the body of this method now actually fits the name of the method, because well, we'll return for a specific condition, but other than that we'll spawn a request. So that does make sense. What's the problem here? Use... Okay, we're supposed to use the 0 method instead of a comparison. And I guess we'll have to, oops, put this in parentheses correctly. Do you really mind this unless? Return if not spawn condition? I think unless is well used here. Return unless the condition is met, basically. Well, actually, I'm not really aiming at the code being readable by normal humans, but by dolts like me, so... Okay, nice. That works, and now we'll basically steal this code and build a round-robin load balancer. Wow. Stuff is materializing. Round-robin LB. No, actually, let's call it load balancer. That makes naming the class easier and more readable. So we'll use this, and we'll say round robin load balancer, which is still an endpoint. And our requests now get spawned in a way where we need to have an iterator. Yeah, it's pretty much a style, code style matter if you use if or unless, or if you consider unless at all. And style, then again, is a matter of personal taste. And since I do have taste, I use unless. How do we iterate over our receivers? Do we use an index? That's ugly. There must be a better way in must be a better way in Ruby where we can iterate over a list and simply say next or something and loop around. Yes. Yeah. What are you gonna do about it? Huh? Huh? Ruby iterate array loop. How to iterate through a Ruby array? Of course, but we need to basically keep a cursor, like on a database. We need to keep a cursor because we don't do a loop in code. Using the reverse each method? No, that's not what I want. Each with index. I guess maybe iterate array cursor might actually get us something. Move the pointer along an array n number of times. Yeah, that's more like it. there's a cycle method. See, I knew that Ruby has something more elegant than maintaining an index or something like that. So we actually I have to test that. That is amazing. But it's still a loop. Ah, crap. It's still a loop. I guess since we don't have a coherent loop, we need to build that ourselves. Yeah, exactly. The joys of asynchronous programming. That's something that I first had to get used to. That everything is controlled by the clock in this game. And that's pretty new to me. That was one of the first challenges that I encountered, where I needed to wrap my head around it. Okay, let's build it ourselves then. We'd simply say we'll call it round robin. That's 0. And then we'll call it pick receiver. That's pretty generic. And another load balancer might simply implement a different pick receiver method, actually. So that might... Yeah, it looks like we are able to actually extract a generic load balancer. And the algorithm will be in the pick receiver method. So round robin will simply implement a different pick receiver method than, say, a least connection load balancer or something like that. Huh, interesting. Oh, I love this. I love this so much. One thing is the game framework, where I get to see stuff flying across the screen, but the other thing is the object-oriented design here. That is so much fun. And exactly, Balthazar, what you say, when the patterns start emerging and I get to do some design that's not predefined by a different framework. Like if I do Rails programming, everything is predefined and I just pick my database tables from which to do my create, replace, update or delete stuff. And that's all. So I don't make many design decisions there. And here I can do all the design from scratch. And I even see the design emerge while I'm implementing stuff. Wow, this is exhilarating. I'll tell you. I'm in a celebration mood. I think I might get myself a beer right after this live stream just to celebrate. This is so much fun. Now let's get our round robin going. Pick receiver means we'll pick receiver will return a receiver, I guess, and we'll actually simply return receivers round robin. I need to research the term round robin and if I'm using this correctly. Maybe I should just use it as robin and robin goes around or something like that. We'll see. Receivers round robin. I guess we call it receiver. equals receivers round robin. Then we'll do a round robin equals round robin plus 1 modulo receiver's length. And then we'll return receiver. And so we can simply call pick receiver here. Like this. And then we'll go into our model, which is in main. And it's not going to be the random request emitter anymore. It's going to be the round robin load balancer with the same arguments. And let's reload our simulation. There is an error. Yes, of course. I think I know what's happened because, yeah, round robin load balancer is not defined in network. It's supposed to be in network though. Round robin load balancing. Well, that needs to be renamed. And let's try and restart everything. Bing. Bong. 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 Oh wow. Oh, what happened here? Yeah, that is amazing. Isn't it a beaut? Look at them flying. Frickin' hell. This is amazing. Balthazar says, to speak to your sensibilities, round robin forwards packets to members of a pool L, where pool member n equals n plus 1, unless n equals L length, then n equals 0. Well, isn't that what I just implemented? I mean, isn't that what I just implemented? No, I was confused for a short moment because it spawned so many requests that it looked like suddenly it exploded all over the place. But it was just a short burst of requests, and I'm pretty sure they still followed the round robin algorithm. But it looked strange because, yeah, it took its time and spawned one and then sprayed it all over the place. Okay, we need to up our rates though. Now, it was a good idea to structure everything in files now, because now I know exactly where to go. We need to go into our simulation model and change spawn min. I guess we can actually say between 10 and 60. Does this... I don't think it'll change immediately. I need to restart the simulation because that model doesn't get created from fresh. Maybe I can do more than GTK reset, which is the game toolkit reset. Maybe there's a more thorough restart here. I guess we could try and do a quick RG $GTK in docs. No, samples. Where am I? I'm in my game directory here. Okay. Let me create a new shell where I'm at the top level. And now let's try, what is there that we can call it in GTK? In samples, nothing. Pretty sure that's okay. There's reset, notify, extend. No, there seems to be only reset. So I guess we'll still have to resort to restarting our simulation from scratch. So why can't I switch to window 2 here? Okay, here we go. Is it going to be enough to see drops? No, it can't. We need to spawn, we need to have either less receivers or we need to fire a lot more requests to see a receiver receive 2 at the same time, or at in a very short time window. So yeah, let's reduce the number of receivers then, because yeah, we don't need 6 of them. That's also in our model. Yeah, I'm very happy about having this main now cleaned up. So let's try and maybe go down to 3 receivers. Let's see. Boom. Okay. It's getting close, but I'm not sure if our spawn rate is right. Oh, there was a dropped one, but yeah, it doesn't happen really often. I'm not sure if my spawn rate is like I want it to be. I mean, with values of 10 and 60, I think my algorithm is wrong. Where's that spawn condition? I think what I want to do I think still doing this modulo is the wrong way to go about it. I think I want to do... Wait, what do I want to do? I wanted to spawn a request somewhere between every 10 ticks and every 60 ticks. So sometimes there will be a second delay, and sometimes there will be 6 requests per second. So yeah, 6 requests per second and 1 request per second. How do we do that? Basically, we do I might not have the brain for math anymore at this point. Is it args, state, tick count, modulo, spawn, max? That gives us a window of spawn max. And if that's greater than spawn min, look at it. No, that's definitely not it. That's not it. So if we had a steady rate, we would simply take this rate and do a modulo and check if that's 0. Every time we pass that specific point. Ah, yes, of course. Yeah, I didn't have any randomness in here. How would that... yeah, we spawned every tick. Yeah, of course. Nice to see that it's still held up. No, what I want to do is... what do I want to do? Do you think it helps if I draw something? Let's see. Let me get my drawing board, my digital one, online. But first I have to get the water bottle out of the way, because that will be a catastrophe. Where's it? Video cable. Alrighty. Log in here. Let's actually clear that up. Speaking of drawing, Balthasar says, I'm still excited for new iPads dropping, but I think, aren't there going to be some later? Also remember that this company exists. Let's see what Balthasar means. And I'll have something to add there as well. Supernode. I don't think I've heard of them. What I did, actually, I backed the Kickstarter of the Vola pad, I think, if I remember the name correctly. It's a Kickstarter that's still going on. And it's a German company that a few years ago did a very successful Kickstarter for their Vola phone. And basically a de-googled Android phone. And now they are launching the Vola pad. And that's going to be either running their own de-googled Android operating system, or alternatively, you can run Ubuntu Touch on it. And I think that's what I'm going to do. I'll try and run Ubuntu Touch on that tablet. So I have a Linux tablet that can do everything that I want to do with it. Hopefully it'll even allow user accounts, so I can finally hand my iPad to someone else in the family without them getting everything messed up. And yeah, it doesn't have a pencil, which is a bummer, but I'll be able to live with that. And maybe we'll find a way to deal with that. But I'm just curious to see how a Ubuntu-driven tablet actually works in practice. Now, let me take a look at Supernode. Supernode.com, is it? Yeah. Okay. Sketchbooks. Let me guess, Android tablet with an e-paper display. Really? did you have to post that? That looks amazing. Oh man. Let me get that on screen actually. So that's the super note. And is it Android based or did they I mean, there are a lot of these things around, aren't there? Sketch something and Notes some other. I think people are still trying a lot of stuff, or companies trying a lot of stuff. Let me see. Why is it more expensive? Low cost, meticulous. Not the greatest argument, to be honest. They have their own software roadmap, so I would assume it's not Android, actually. Android? Not mentioned on the page. Interesting. So they built their own platform there? Which is impressive on one hand, but also worrying on the other, because what if they stop developing software? Or what if they don't develop the software that you would like to have on it? Let's see, creative writers. Handwriting, backup, cloud sync. Yeah, okay. Nice. I'm impressed. And let's see. What does this cost? In Equatorial Guinea. No, in euro. Where's the euro? Give me euro. There is no euro. Why is there no euro? Can't be serious. Wait, what? Can't be they support every currency under the sky, but not euro. Huh? That is strange. They don't... Yeah, it looks like they only sell in dollars. But to everywhere in the world except Europe. Are you serious? They do sell to the United Kingdom. What? This is... That's not right. Can't be. Anyway, how do I get a price? Okay, here we go. Supernode Nomad, that's the small one, I guess. Okay. $2.99, that's decent. That's definitely good. The Folio, I guess that's the A5 one. $3.88, that's still good. Yeah, the Folio is A6 and the other is A5. Okay. Pricing is decent for a limited device that does not seem to support Android, which I would expect, because other tablets of that ilk do use Android or something like that. How does IT and engineering work? Visualize, okay. Workflow, yeah, that's writing. Annotations, that's something that I can use, but I guess they just do PDF annotation. Dropbox and Google Drive. Did they actually build their own software? Let me catch up with chat here. Nomad is newer, but then and cheaper. E-paper. Yes, I agree. Supporting an open source community and doing both hardware and software dev is hard. Yeah. I think that's fair. It's just, of course, more limited that way. You said picked by country. Well, there isn't any EU country in there. It looks like they actually do not sell to the EU because Ireland is missing from here. And I mean, let's take something bigger. Germany isn't in there as well. So that's really strange. Maybe it's about regulations or stuff? Strange. But interesting. Definitely interesting. So let's get back. What did I actually want to do? Yes, the conundrum of the randomized spawn rate. Now, let me see. I need to rearrange my desk a little bit here. So this needs to be in reach. Okay, that's better. So we have a timeline. We have a pencil that's not charged. Give me a minute. So we have a timeline that is ever expanding. We want to determine, okay, let's leave at least this time before we spawn a new request. And at max this time. Oh yes, VAT might be also something like that. Yeah, maybe they want to deal with that. Don't want to deal with that. That's possible. So let's see if the pencil now works. Should only have to charge a little bit. So here we have our timeline. And let's say we've spawned a request here. And we want to have at least this amount of time until we spawn. During this time, nothing may spawn. And then we have a longer time frame where we can spawn somewhere, let's say here. And then we need again our short cooldown time. And then we have another window where we can spawn, let's say here. And again, short cooldown time, actual spawn window, and let's choose something more near the end. And that way we randomize our requests, but there's a specific cooldown time. Okay, so And this here is our min. And the whole thing, that's our max. That means do we have to track? I think we have to track when we did our last request, don't we? Because we need to account for the cooldown. If that's what we want. Do we necessarily have to do it this way, though? Ad break gives me a little bit of a little bit more thinking time. Let's charge the pencil in that during that time. So I think if we want to have a minimum time, that requires tracking a cooldown. But we could also just have a randomized... You know what? Of course. We'll just randomize it over max minus min. Yeah, of course. Yeah, I think I got it. We'll just randomize over the difference here. And then add min. That will make sure that distance will always be at least min, because if our RNG gives us 0, then we'll have at least min. And otherwise we'll have at least we'll have something near max. Yeah, I think that should do it, right? Let me put the pencil where it belongs so it can charge. No? Grab onto it. Okay. Okay, so that would mean it's args state tick count modulo spawn max minus spawn min. No, we need to randomize that. Wait. Yeah, no, it's the modular actually. We do a rand. Add spawn min plus a random over the rest of the time window. Let's see how this works. Yes, we have deferring Uh-huh. That looks like it's doing what it's supposed to do. But with 3 receivers, we still see drops only rarely. So we need to actually up our game here. If that is correct... Ooh, look at that. Yeah, they are not overlapping, so there's no interval in the below 10 ticks, but they can be pretty close. And we could even visualize that by having a drop counter or something like that. All right, getting there. If I don't allow... first of all, let's actually fix this formula as well. And if I go back to my main and we say, okay, actually make them closer to each other. Now let's focus on our first receiver here. Boom. 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 Oh, yeah. Yeah, I can see it, how it happens. It's hard to keep all of them in sight, but if you focus on one of them and there are 2 subsequent requests in short distance, then yeah, you can see how they get dropped. What we also could do is, of course, vary the processing time. Our receiver has a fixed processing time. We can change that. Where are we in time? Actually, I'm past 5 o'clock. Okay, that's going to be the last thing that I'll do. My receiver, where does the receiver actually have its busy time? It's busy duration, but busy duration? Where is busy duration defined? Is that still in endpoint? Oh, yes, it is. That's not where it belongs, actually. Receiver... busy duration is 40. If we increase that to 60... not sure if this gets reflected right away, so let's restart the simulation. Yeah, and now we see a lot of drops because, yeah, it takes far too long to process a request. Nice. Yeah, that's actually pretty good. There are times when stuff is slow, like now, but if there's a short burst, then our receivers, our servers are just too slow to accept more requests. I love this. Yeah, look at those bursts. You almost can't tell that it's round robin anymore. Ah! Yeah, that's not good. And that's actually reality. I mean, if you have a load balancer or if you have such a setup, sometimes stuff just comes in bursts. I mean, a single page request, for example, or a single triggers a bunch of requests for CSS, images, fonts, all kinds of stuff. So sometimes even if you don't have any caching in place, your application server might actually even get overwhelmed by a single page getting visited and everything needs to get served to the visitor. So it's not unrealistic that those requests come in spurts with a few pauses in between then. What would be nice is if our model would center everything and spread stuff out a little bit. But I guess that's something for another day, because I think we've reached a good point, and I'm already over the 3-hour mark here with my stream. So this was a lot of fun. Okay, let's commit this. And I need to set up a repository as well. But maybe I need to do a little bit more refactoring in terms of file names and stuff, so we can actually have different models, because at the moment everything is in main. Well, this round-robin load balancer scenario is only one of many, so I need to find a way to handle that as well in my file system here. And once I have a grasp on how to structure that, which is probably going to happen on Thursday, then I can actually publish this and you can take a look at the code yourself. All right, until then, let's commit this. Call it round robin load balancer. Now that's backed up. And okay. Let's catch up with chat as well. Bethesda says, I remember the first app I ever deployed that taught me that caching is important. That was MediaWiki. Yeah, I can imagine. Especially if it was early days. I mean, you don't think that MediaWiki would be so heavy, but it does probably a lot of lookups in between and internally for all kinds of stuff. Maybe it even looks up all the references between pages and stuff. And yeah, that can take a long time. But it's the same thing with the Drupal and WordPress websites that my company is hosting. Stuff can just take a lot of time to render. We have websites whose pages do 100 database requests per HTML page. And so caching is vital to create not only a great visitor experience, but also reduce load on our databases and on our application servers. Database caching is important as well, yes, yeah. So stuff like memcached and things like that definitely help as well. Okay, folks, this was a lot of fun. I mean, I haven't had as much fun coding in quite a while, to be honest. This was very well worth it. If you'd like to continue the chat, join us on our Discord server. And if you'd like to have a more long-term learning experience, then definitely check out the server room, my new membership community for DevOps people. We are going to launch into quite a few events where we'll have a hangout soon, another hangout at the beginning of May, and in the middle of May we'll have a deep dive where I actually showcase my Linux setup here to members of the server room. And I'm also working on our first community workshop where we're going together set up a statically generated website on a VPS using Jekyll, Apache as a web server, Certbot for SSL, and Git for deployment. So that's definitely also going to be fun. That's going to be the first of my self-hosting workshops, because that's what I'd like to focus on. I'd like to teach people the abilities to do self-hosting themselves, or if things get a little bit more complicated, for people to provide hosting services to people who want to have control over their own platform, for creators, artists, writers, all kinds of people who don't want to use the probably soon to be unshittified platforms like Substack, like WordPress.com, like other platforms. So I'd like to either enable the creators themselves to do self-hosting, or people who want to serve creators doing so. And that's why I'm going to start with a simple website scenario where we're going to go through all the steps necessary to set this up. I'll explain how everything works. I'll comment on Linux system administration practices and all kinds of stuff. So I'm really looking forward to this first community workshop. Not workout, workshop. I do need a workout though, so I'll wrap things up. That's that. So I'll be back on Thursday at 2 p.m. Irish time, which is 12 p.m. UTC, where we'll continue working on this simulation, and we'll probably do a little bit of improvements in on the visual side, but we'll see where things take us. This has been a lot of fun, not only because I got a lot done, but also because of all the conversations we had. So thank you so much for that. And I'll be back on Thursday. Hope to see you then. And until then, take care.